Today we're talking about using the unit circle to evaluate trig functions. So if you remember the plate activity we did, there's these triangles that we filled out using the special right triangle formulas. In my notes, I've copied down the 60, 30, 90 triangle with all of the sides. So these are right triangles, and for that reason, we know that we can apply to each of those three triangles SOHCAHTOA. That's just basic right triangle trig. This tells me that sine of theta is the opposite over hypotenuse, cosine is the adjacent over the hypotenuse, and tangent theta is the opposite over adjacent side. When we were doing problems with this before, we would label across from the 60, that would be our opposite side, adjacent, and hypotenuse. But now that we've put these triangles on the coordinate plane in standard position, we don't need to always label as opposite and adjacent any longer. If we're looking at this one, opposite and adjacent. What you can think about is that that's the x component of the triangle, and that's the y component of the triangle, and that's directly related to the coordinates. So our labeling, instead of now being opposite, adjacent, and hypotenuse, we'll call this x, because that's the distance in the x direction. That's the distance we're going in the y direction. And 1 is not just the hypotenuse, it's actually the radius of our unit circle. So we can label with x, y, and r. Now for that reason, we can consider that sine of theta is y over r. Cosine is x over r. And tangent is y over x. But since we're on the unit circle has a radius of 1. So all of these formulas, well, these two at least, can be simplified in that sine of theta is equal to y, cosine theta is equal to x, tangent just stays as y over x. So what I'd like you to do is take those formulas and copy them down on the back of your paper plate. We should already have things about the unit circle. So what I want you to write down is that sine of theta is y, cosine theta is x, and tangent theta is y over x. Just make sure that's on the back of your paper plate. So let's do a simple example. Take a look at this 30-degree triangle, the 30, 60, 90. So we're going to talk about sine of 30. Sine, we know, is the opposite over hypotenuse. So in this case, it would be 1/2 over 1. But now we're labeling them as x, y, and r. So now sine is y over 1, 1/2 over 1. So what you can do is look at any of the coordinates, and the sine value for that angle is just going to be equivalent to the y part of the coordinate. So sine of pi over 6 is 1/2. Sine of 45 is root 2 over 2. Sine of pi over 3 is root 3 over 2. So let's take a look at one or two examples together. Let's take a look at cosine of negative 30 degrees. Well, negative 30 degrees, that's the same as 330 degrees. Those are coterminal. So finding cosine of negative 30 will be the same as finding cosine at 330. So what I'm going to do, I'm going to go to the unit circle and find 330 degrees, and cosine is just going to be the x coordinate there. So the answer is root 3 over 2. We can do that, another easy one, sine of 7 pi over 4. This is within one loop of the unit circle. I shouldn't need to add or subtract 360. I'm just going to go to 7 pi over 4 and look at the y coordinate. So the answer is negative root 2 over 2. One more example we can look at, sine of negative 29 pi over 6. Now, when I see negative 29 pi over 6, I know I'm going to want to get that to within between 0 and 2 pi. So I'm going to find a coterminal angle by adding 12 pi over 6. In this case, I have to do it 3 times to come out to a positive coterminal angle, so 7 pi over 6. So this problem is the same as finding sine of 7 pi over 6. So on the unit circle, go to 7 pi over 6, and sine is just going to be the y-coordinate, so -1/2. Here are some for you to try on your own. If it ever focuses for us, there we go. And now the answers are here written in like the gray part.